Hello there and welcome back to the dam. Today I will do a follow-up on my video about 128 megabytes of 30-pin RAM on a 486. And if you haven't seen that video, I will recommend that you take a look at it before you watch this video. Link is in the description below. First off, I would like to say thank you for all the comments and feedback that I have received on my first video on this subject. In this video, I will try to do my best to address all of your concerns and suggestions. I would also like to say thank you to the sponsor of this video, PCBWay. PCBWay very kindly reached out to me after seeing my first video and offered me a sponsorship. And as you have already guessed, I of course accepted their offer, but more on that later in this video. This video will be divided into two sections. In the first section, I will make a list of things to improve on this memory project based on your comments and suggestions. And if that sounds too boring to you, feel free to skip ahead to the second section where I will implement and test these improvements. First comment is from Burn0U71 and he points out that 128 megabytes of RAM on a 486 is useless and a waste of time. And to that I will say I absolutely agree, but this project is not about making a useful 486. I do this project mostly to satisfy my own curiosity. I am fully aware of the fact that in most use cases for a 486 you would be best off with no more than 32 megabytes of RAM. I just like to tinker with retro computer things that is a bit out of the ordinary. Next comment is from Pato Developer. He asks about the cost of these DIY RAM, and to that I will say that in the end of this video I will break down the cost of these memory sticks, and I will also tell you where you can source the PCBs and the memory chips for these RAM sticks. Next up we have a comment from Sebastian 19745. And he points out that the problems I had with the RAM in the first video might be caused by the lack of parity on the memory sticks. And that is certainly a good point. So I will do a complete redesign of the PCB for this memory, and I will add support for parity chips. And that will hopefully alleviate some of the problems that we had in the last video. He also points out that MS-DOS 6.22 that we used in the previous video only supports a maximum of 64 megabytes of memory. And that is a good observation. I have done some research and I can confirm that MS-DOS 6.22 only supports a maximum of 64 megabytes of memory. So for the next test I will be upgrading to MS-DOS 7.1, and that should give us support for 128 megabytes. Kenneth Schaft mentions the relationship between RAM and cache. So let's have a look at that. Here we have a chart of the relation between cache and RAM. And for our motherboard that supports a maximum of 256 kilobyte of level 2 cache, we can see that if the cache is running in write back mode, we only have support for 32 megabytes of RAM. And if the cache is running in write-through mode, we have a maximum of 64 megabytes. If you have a system with more RAM than the cache can support, you will get a performance penalty. And that penalty could, in theory, eliminate any gains that you made from adding more RAM in the first place. Next, we have a comment from something that I can't pronounce, 33. He doubts that the SIMM 16 designer made the dual voltage PCB without consideration of the data line voltage. And he could be absolutely correct about that, but in my research, the data lines on the SIMM 16 design would exceed the threshold for the 3.3 volt memory chips, but let's check that with an oscilloscope. Here we are back on the bench, and I have set up our FIG486 test motherboard, and let's try and measure the levels on one of the data pins on the RAM. And as you can see here, we have a peak voltage of 5.2 on the data lines on the RAM in this motherboard. So I think I will stick with my claim that the SIMM 16 design with the voltage regulator is operating the 3.3 chips with a much too high voltage on the data pins. But this could of course differ between motherboards. And with that, I think we have covered the most important comments and feedback for this RAM project. So let's see what we got on our to-do list. Here we have our final to-do list, and the first thing is to do a redesign on the PCB so we can add support for Parity. We also need to upgrade our test setup to MS-DOS 7, but that is a minor detail. And we should of course note that 128 megabytes of memory on a 486 is stupid. And we should also note that we don't have enough cache on our motherboard to effectively use all of the 128 megabytes of RAM. I would also like to give a big shout out to Uplate Geek and Rick Red, the creators of the SIMM 16 and the 4 megabyte SIMM module. You can read their feedback on this project in the comment section of the previous video. And now let's switch to KiCad and do the redesign of the PCB. Now that the redesign of the PCB is ready, I just want to mention a couple of things. First, I am aware of that the SIMM 16 project already includes a design for a PCB with Parity. The problem for me with that design is that it is using a single bit chip for Parity, and I couldn't find a single bit chip with the same specifications as the 4-bit chips that I use. So in my redesign of the PCB, I just use 3 of the same 4-bit chips. Also, the SIMM design with Parity is a 4-layer board, and I would like to keep it as a 2-layer design to keep down the cost of the PCB. With that said, I will now send the design files to my PCB manufacturer, PCBWay, which is also the sponsor of this video. PCBWay is your all-in-one manufacturer for PCB prototyping, CNC machining and much more. They offer rapid turnaround and prices for 2-layer PCBs starting from only $5 USD. And you don't have to be an expert in PCB design to order from PCBWay. With their Shared Projects section, you are only one click away from ordering your next PCB. Here you will of course also find my memory PCB, so you can start creating your own memories. Right now the countdown to their anniversary has begun, where you get exclusive coupons, extra discounts and much more. So join PCBWay today and make your projects a reality. And thank you to PCBWay for sponsoring this video. And now back to the bench. My order from PCBWay just arrived, and let's go ahead and open up this box and see what we got. Very exciting. Like that. And we have foam packing. And this is the stencil for the PCB. This time I remembered to order a stencil. We will need that later. We have an invoice, and we have some lovely PCBs. So let's get the box out of the way, and let's open up one of these. Let's break into this bubble wrap and free our PCBs. Let's get this rubber band off. And whoops, we are upside down. These memory sticks is looking very good. Just as always when I order from PCBWay, they seem to always deliver a good result. Now we just have to hope and pray that I didn't screw up in the design process. And there is only one way to find out. And that is, of course, to assemble some of these memories and put them to the test. Now that our new RAM sticks with Parity is ready, we need a motherboard to test them in. And for that I have this board. And if you saw my previous video on this topic, you have also seen it before. It is the FIC 486 VC-H. And the reason for choosing this specific motherboard is because the official manual for the board states that the board supports up to 128 megabytes of memory. But what you might also know is that in the previous video I didn't manage to get this motherboard running reliably with 128 megabytes of memory. And I don't think it's because we didn't have parity on the memory last time. I just think that there is something up with this motherboard. Not that it is defective, but the chipset, I really don't like the chipset, and I think that is that has a great part in why this motherboard is so unreliable. I don't think it's because there is any loose connection or loose pins. It's just yeah, it's just a crap board. So I found two alternatives for this motherboard that we can test our new RAM with. And the first candidate I have for test motherboards is this UMC board. It's the UM4980 version 2.1. And according to the manual, this motherboard will support up to 1 megabyte of cache in write-through mode, and that would mean support for up to 256 megabytes of memory. But as you can see, this motherboard is using 72-pin memory and not the 30-pin memory that we just made. But that problem could be solved by using something like this. It is called a SIMM verter, and it simply adapts three 30-pin memory sticks to a single 72-pin memory stick. And if we had 4 of these converters, we could in theory put 256 megabytes of memory on this 486 motherboard. But these adapters, while they fit fine on the motherboard, you can see that putting in a single adapter would block off the next SIM socket. So in reality we would only be able to install 2 of these monstrosities for a total of 128 megabytes. But I only have one of these SIM verters, so it is really not a option here. But maybe in a later video I will come back to this motherboard, and it is quite interesting, I think, because it supports 1 megabytes of cache in write-through mode, giving us the support for possibly up to 256 megabytes of memory. But that will have to be in another video. For now, I think this motherboard is our best candidate for a test motherboard for our new 30-pin SIM memory. It is the OCTech Hippo VL Plus, and let's start by having a look at the retro web page for this motherboard. Here we have the page for our Hippo motherboard, and the first thing to notice is that this motherboard is infamous for having no level 2 cache. Instead, it relies on this special OC-Tech DCA technology. The DCA stands for Dynamic Cache Architecture, and in short it means that the RAM has a built-in feature that replaces the normal cache, and it does so with improved performance compared to a regular setup with separate RAM and cache. Sounds almost too good to be true, right? And apparently it was too good to be true. An interesting story, and maybe something I will dig into in the future. But for now, let's just note that this motherboard has no cache. At least that eliminates the possibility for any problem with our new RAM being related to the cache. Second thing to note is that this board is listed to support only 32 megabytes of RAM. But speaking from experience, I know that not all information on the retro web is accurate. I think there is a good chance that this motherboard will support 128 megabytes of RAM, especially given that we have a BIOS image for this board from 1995 that supports up to 2 GB hard drives. It would make sense if that late BIOS also included support for 128 megabytes of RAM, but let's just go ahead and test that. Motherboard has now been set up with our old RAM with no parity, 128 megabytes, and I have also plugged in our flash card with MS-DOS 6.22, and we are still on the original BIOS that apparently only supports 32 megabytes of RAM. And this is just a test to give us a baseline. So let's see how this goes. And let's power on the board. And let's see how much RAM this board will detect in this configuration. I expect it to detect only 32 megabytes as stated in the manual. But let's see. Maybe we get the full 128 megabytes. And we are now past the 32 megabytes, so let's just wait and see. This is counting up very slow. Okay, so we got only 64 out of our 128 megabytes. But since we are still on the old BIOS, that is totally fine. Let's try and see what we have for settings in the BIOS. And here we have a switch for parity check, so we can apparently enable or disable the parity check, and right now it is set to disabled, and that would fit our current setup with our old RAM that do not have parity. So let's just try and see if we can boot the system with this configuration. And it looks like it is working. If we had any parity errors, we would probably already have seen it. And immediately I can see that our keyboard is not working. So it was working in the BIOS, on the BIOS screen, but not in DOS. Let's try and reboot again and turn on the parity check and see if we get an error after enabling parity check with our non-parity RAM. So now parity is enabled. Let's see how that goes. And we immediately get a parity error. So it seems like parity check on this motherboard is working. But let's try and upgrade the BIOS to the latest 1995 BIOS and also plug in a CF card with MS-DOS 7 and see how that goes. We have now installed a new BIOS and also MS-DOS 7. We are still using the old non-parity RAM, so let's try and boot the system and see if we get the full 128 megabytes this time. And it looks like we only got the 64 megabytes of memory still. But let's check it in MS-DOS also. And the keyboard is now working after we changed the BIOS from the AMI BIOS to the Mr. BIOS. So that's a good sign. Let's see if what we have for memory. And we only have 64 megabytes. So that could be because we don't have parity, but let's check the BIOS and see if we have any settings for parity. Let's see. And I don't see any options for changing the parity check now. We had that in our AMI BIOS, but not in this BIOS. But we have some options here to change the timing for the memory, 60 or 70 nanoseconds. Memory remap. Is that parity in this BIOS? Let's try and change it to no and see if no, that didn't change anything, but let's see if we have more than 64 megabytes now. And we don't. So let's try and plug in our new Parity RAM and see if that changes anything. So there you have it, 128 megabytes of Parity RAM on a 486. This has been a long journey, but I think I can say that in the end we reached the goal. I know that there is a lot more to say and to do and to test with these RAM. But this video is already way longer than I initially intended it to be. So this is the end for me and this RAM project, at least for now. I have tested these RAM against the previous design, and all my testing indicates that the parity on these RAM is working as intended. But let me know in the comments what you think about this PCB design. I am not a professional PCB designer, so there might be something that can be done better. The only thing I have left now is to give you a breakdown of the cost of these RAM, and I will also tell you how you can get hold of some of these RAM yourself. And here you can see the total cost of these RAM. For the PCBs, I of course get them at PCBWay, and for that I have paid 95 euro cents per board. The price is a bit higher than a standard PCB, but that is because I chose the medium thickness gold finish for these RAM. If you just go with the regular tin and lead finish, you can of course get them for a lower price. But still, with the gold finish, I think the price is very reasonable. For the solder paste and the capacitors, I have ordered it from AliExpress, and that comes out to around 25 cents per board. And finally, the RAM chips themselves. I sourced these on Alibaba, and I got them for €2.30 a piece when buying them in these bags of 200. 200 chips is of course a lot to order if you only need a set of 4 or 8 RAM sticks. So I will sell my surplus of these chips on eBay, where you can buy 12 or 24 chips for your own RAM PCBs. You can find the link for my eBay listing in the description below. If you decide to try out some of these 16 megabyte memory sticks yourself, there is some important things to note. First, support for 16 megabyte RAM sticks is heavily dependent on what motherboard, BIOS, CPU and other hardware you have. So make sure that you have a combo that will support 16 megabyte RAM sticks. Next, make sure that you use an operating system that can support 128 megabytes of RAM. Also, the software you want to use needs to support the full amount of RAM. In my testing, I found that a lot of programs will only support up to 64 megabytes of RAM, even when running on DOS 7 with support for 128 megabytes. And I think that's it. So I hope you enjoyed this video, and if you did, don't forget to press the like and subscribe button. Leave any comments you might have in the comment section below, and I will see you in the next video.